What is happening, everybody? Today's episode is dedicated to a particular individual who asked a very good question in class, and I apologize for not being able to do the problem, but here we go. I told you I wouldn't leave you hanging, so I am not going to leave you hanging. Let's rock and roll. The first part in Part A of number 25 from the book here was to use a Maclaurin series to manipulate and eventually come up with x over 1 minus x squared and represent that as a power series. So we got this far, and there was no question there. Unfortunately, I was not able to do B and C, so let's just go and get those off the ground. It says, use the Maclaurin series obtained in Part A, which is this guy, to find out f, the fifth derivative at x equals 0, and the sixth derivative at x equals 0. Well, let's talk about this for a second here. What they want us to do is they want us to make associations between what these individual terms are here, here, and here to the basic Maclaurin series polynomial. So when we talk about the series up top here in yellow, when we talk about this series being x plus x cubed plus x to the fifth plus x to the seventh plus x to the ninth, actually that's not totally accurate, because what happens is that if we were to actually derive this thing out multiple times, what we would find is that this is actually 0, right? We would find that x over 1 minus x squared is actually equal to 0 plus x plus 0 plus x, x squared plus x cubed plus 0x to the fourth plus x to the fifth, which is why all of these 0 terms end up getting canceled out, which is why in the power series above right here, we skip all of the terms that are even. So why is this important? Well, it's because when we do a polynomial expansion using a Maclaurin series, we say that p of x is equal to f of 0 plus f prime of 0 x plus f double prime of 0 x squared over 2 factorial plus f triple prime of 0 x cubed over 3 factorial plus f 0 x to the fourth over 4 factorial. And I apologize, I was trying to get these to line up perfectly, but I wasn't able to do that. But it's the fifth derivative of f at 0 x to the fifth over 5 factorial. So very similar to partial fractions, I will solve this using association. In other words, I will associate my x to the fifth term with the basic x to the fifth term. So how do I do that? I'm going to say, actually I'll do it down here. I will say that x to the fifth, which is the fifth degree term in my Maclaurin series, will be equal to the general fifth term of a Maclaurin series. And remember, they want us to find f5, right, the fifth derivative at 0. So what I'm going to do is I'm literally going to solve for it here by multiplying both sides by 5 factorial. X to the fifth is equal to the fifth derivative at 0, x to the fifth, and then the x to the fifths will cancel each other out, and that is why the fifth coefficient is going to be 5 factorial. Now what this is saying, what this answer means is that if you were to derive this expression 5 times, right, to get the fifth derivative down, the coefficient on the outside would actually be 5 factorial. If you did it in a derivative calculator, they'd actually multiply 5 factorial out. I believe it's 120. But yeah, you would get 5 factorial as your coefficient of this derivative 5 times. So that's the interpretation of that answer. So I'm hoping that explanation made sense to you. Now at this point, I'm going to take on the sixth derivative term. Now, in order to do that, what I'm going to see here is, based on the pattern that I'm seeing in the yellow here, is that every even power seems to have a 0 attached to it, so 0x to the sixth. So what I'll do is I'll solve by association yet again, and I'm going to go ahead and say that 0x to the sixth is equal to my sixth derivative general term here, which is f sixth derivative 0 x to the sixth over 6 factorial. And I think you'll see that the x to the sixths cancel each other out, and the 6 factorial, when multiplied over, will go to 0. So the sixth derivative at 0 would be 0. So hopefully that makes sense. with b, and then the reason why this problem is happening here is because they're trying to see if you can establish a pattern for part C. So let me clean up the board real quick, and then, actually I don't think I even need to clean up the board. So in part C. Part C is saying, what can you say about the value of f the nth derivative at 0? Well, it seems to me, when they talk about the value of the coefficient, what happens is that it turns out it looks like it's going to be n factorial, right, if n is odd, and then it looks like it's 0 if n is even. Let's see if that's true, though. Okay, let's see if that's true. When it comes to the 5, right, the 5, we end up getting itself being factorialized. And then the 6th one is 0, and we kind of saw that happen with the terms that are 0. They're always the even-powered values of x. So I hope that makes sense. Let me know if you have any questions or comments. Just post them into the comments section. And thank you for asking the question. I enjoy the challenge, and hopefully this makes sense to you. But if not, go ahead and let me know, and we can see if we can clarify it in the next class. I will see you guys later.